Hey everyone, my name is Tom and I'm going to be tutoring the upcoming Introduction to Cognition course. And I'm very excited to tutor that. So I thought I'd make a little video to explain one of the topics just so you get a feel for what the session is going to be like. So a little bit about myself. I'm currently a second-year psychology student and I've had quite a bit of tutoring experience in addition to tutoring the previous two Introduction to Psychology courses. So I'm going to be talking about vision and more specifically the organizational features in the V1. So there are four main organizational features as you can see here, and we're going to go through each one of them more specifically. The first one being topography. And what that means is that the V1 is organized using retinotopic organization, and that means the objects that are closer together in the visual field are also closer together in the primary visual cortex. So as you can see, this is an example of the visual field. So for example, number 9 and number 10 are close to each other in the visual field, and they're also close to each other in the brain. And that's the same for all the other numbers as well. The next way that the visual field is that the visual cortex is organized is using cortical magnification. So as you know, the fovea is the area where there are the most cones, and that means that's where you get the clearest image from. So information coming from the foveal area actually occupies a larger area in the V1 than parafoveal information or information from outside of the foveal area. So size is unevenly distributed, but our brains can make sense of it. And this can actually also be seen in this image. So as you can see, number 1 is specifically where the fovea is. And although number 1 is much smaller than number 9 in the receptive field, when you look at its size in the brain, it occupies a lot larger of space than number 9, showing cortical magnification. The third way in which the brain organizes visual information is cortical modularity. And what that means is that we have ocular dominance columns, and there's actually a lot of information that is still unknown about them, but what we do know is that we have different strips of neurons, and each strip responds more predominantly to information from one of the two eyes. So as you can see, some respond better to information from the left eye and others respond better to information from the right eye. And lastly, we have receptive fields. So I'm only going to get into this briefly because this is a slightly more complicated topic, but I'll go in depth about it in the actual course. So receptive fields of the neurons is the area in the visual field that causes the highest activation of the neuron. And this is determined using an electrode that gains single cell recordings. So the cat is presented a light bar on the screen with different orientations, and it checks the activation of that specific neuron. And as you can see, the straight bar actually activated the neuron the most, and the flatter the bar got, the less the neuron got activated. And this can be seen in this graph as well as this. And what this experiment did was that they determined the tuning field or the orientation at which the neuron fired the highest. So that is the basic idea of the receptive fields. So that's it for today, but I really hope to see all of you on Saturday for the first Introduction to Cognition course. Yeah, thank you so much for watching this video, and I really hope to see you guys.